Our next speaker is Ben Hansen. Ben, you want to know how long we've known each other?
No, I don't.
Good. 30 years, telling you anyways. So Ben's going to talk about the test of heightened election year scrutiny and the test in your table 1. So Ben is an associate professor in the Department of Statistics at the University of Michigan and research associate, Survey Research Center, Institute for Social Research. He received his PhD from the University of California, Berkeley. Dr. Hansen's research develops methods that aim to sharpen comparisons of subject receiving an intervention to subjects receiving a control condition, particularly non-randomized comparisons, and to improve communication and understanding of remaining uncertainties regarding effects of the intervention. He writes on statistical and computation issues related to matching, on diagnostics for randomized studies and for matched observational studies, on sensitivity analysis, propensity scores, and related methods of dimension reduction sensitivity analysis. And he's a co-developer of R libraries for optimal matching and associated diagnostics. His current focus is on causal inference and comparative studies, particularly observational studies in the social sciences, which we're seeing many important ones these days. All right, thanks, Ben, for participating. Take it away.
Hey, thank you for inviting me, Rafael. Thank you very much for putting together this excellent menu of talks, and thanks a bunch to the other speakers for these great talks I've heard so far. So my talk title here mentions table 1. I shortened it just a tad to fit it on the slide. By table 1, I'm indicating that the thing that we all expect to see near the front, maybe table 1, maybe table 2, but near the front of a comparative study, especially of people, where a comparative study where you have a treatment and a control group, and you expect to see a table showing us what the baseline characteristics of these people were before they received or didn't receive whatever intervention is under study. It's a very common table to have. Whether or not such a table should have measures of statistical significance to go with it is a very common topic of seminar room debate among statisticians. I myself enjoy that seminar room debate, and indeed, over the course of the talk, you'll hear my perspective on it. But the point of this talk is not so much to grab you as that, to drag you through that, as to trace the consequences of this debate and some of the issues about communication as they wend their way directly or indirectly through discussions about the Affordable Care Act and associated expansions of healthcare. So I have 2 examples drawn from that debate in which, in one way or another, you wind up with some trouble from table 1. The first of these comes out of a lit review that was published shortly after the November 2016 election. It actually came out in the summer of November 2017. These are the highlights of this lit review, the authors of the lit review. The highlights of it was published in the Annals of Internal Medicine. And you can see what the authors are telling us. They're telling us that at that time, their update to include recent studies on this issue added one big randomized experiment and some other studies, which in the aggregate tended to support the conclusion that there was a mortality benefit that attended to these expansions of health insurance. This highlight speaks of a single randomized controlled trial that looked at this issue. And that might seem a little bit small, and indeed it is. So first of all, this lit review was presented as sort of an update that was reviewing recent entrants in the literature. There had been older experiments from an older area that had been discussed in prior lit reviews. But this wasn't the only experiment that had been published on during this time period. There was one other experiment that had made its way into the literature, in addition to a number of quasi-experimental studies. Those quasi-experimental studies were on the whole bigger, and the lit review sort of wanted to focus on those more than on this other experiment besides the Oregon health insurance experiment. So this one other experiment that's mentioned there is a flawed RCT, at least according to the authors of this lit review, that was carried out by the Social Security Administration. And in this flawed RCT, some randomly selected applicants to the disability program would receive extended Medicare benefits earlier than others. But it's described as flawed because the randomization apparently failed. And that apparent failure of the randomization, it's going to turn out, we'll see, traces back to their table one, a table one that had been presented with the study. So let me show you that table one, or at least an excerpt of it, here in my next slide. So here is the better part of table 1A of this Social Security Administration study. The authors are Bob Weathers and I think it's Michelle Stegman. Their names in the full citation are listed at the top. But as you can see at a glance, looking at this table, on the one hand, it's a little more complicated than some of these studies. There are three groups. There's a control group. There are two different versions of the treatment, listed as AB plus and AB. You see the usual demographic characteristics. There was more in the table. I haven't given you all of it. I give you the top and the bottom of the table. And you can see, taking it at a glance from the table, that there are various points in the table where there are significant stars. Now, the lit review that I showed you a bit of, it didn't harp on all the significant stars. It was interested in specifically in cancer. And I've arranged this table so that you can see that significant star or pair of significant stars on the entry for cancer under AB plus versus control. It's sort of the stronger version of their treatment versus the control condition. And right there in the middle of the table, yes, indeed, there is a difference between those two of 4 points that was significant enough to merit 2 stars. Now, looking at this as a statistician, and especially if you're in one of the many branches of statistics where you have to think about multiplicity, a question immediately arises: what was done, if anything, to address the multiplicity of these comparisons? Because, of course, cancer in those two groups was not the only comparison being made in this table. There are many. As best I could tell, there actually were no multiplicity corrections being made here. So that 5%, well, you know, that 4% with 2 stars by it, maybe that was more cancer than you would expect to see, or maybe this was just chance having its word in a table of a whole bunch of different comparisons. Now, the authors of this study did do something to address that issue. And if you look at the text of their paper, you'll see that they're calling out very clearly there that they think that the place to look for some validation of this trial is not at any one of these entries up above in the table, but in multivariate tests. They present you 3 of those at the bottom. They're F tests that are being done, and you see them. If you can see my cursor, I'm not sure you can. The F tests are down here, sort of at the bottom right. You see the 3 p-values from those tests of 0.20, 0.45, and 0.05. So from that perspective, things look less alarming than they might have looked if you just looked at the table and tried to find a significant star. But you might still feel a bit alarmed to see that 0.05. It too, strictly speaking, we might have demanded a multiplicity correction to interpret it alongside of the other 2 multivariate tests, and then the hint of significance would have gone away. A brief divergence into the technical issues about multiplicity are that one can make a strong argument just from interpretability of tests that this regime of tests being presented is not coherent, and making it coherent would have quickly erased all of the significant stars that you see in the table, making the variable by variable test coherent with the multivariate test at the bottom. So I'm offering this as a first example of table 1 significance stars or significance testing in practice And here, the net result of it was to raise a false alarm and directly or indirectly lead to one studies being excluded from the evidence base considered in that lit review. That was my first of two examples. And I'll march right into the next one, which also comes out of the same debate about what you get in terms of mortality benefit from expanding health insurance. So here I have another key findings excerpt from another paper. This paper was actually one of the papers that had been reviewed in that review we were just looking at before. This is sort of a landmark paper by some Harvard authors, noted here at the top, who were looking in a quasi-experimental study at the experience of people living in Massachusetts before and after the expansion that happened there in your state back in 2006, and looking at them in comparison with the mortality trajectories of other counties around the country, not all other counties, but a subset of some 500 or so counties that had been selected as similar to Massachusetts counties on the basis of a preliminary propensity score analysis. So the analysis that Summers, Long, and Baker, I'll call them SLB, presented here were sort of based on the union of this preliminary propensity score stuff and a conventional regression analysis, negative binomial sort of modeling that built upon that. They published this in 2014. In 2016, the health economist Robert Kessner published a paper in Statistics and Public Policy saying, hey, look, I tried to replicate this study and I could only replicate it in small part, maybe not the most important part. Here's an excerpt of his paper in which he describes what he did. The sort of thing he did will be of interest to people who take an interest in propensity score methods and the sort of things that go with that, as I do. He said, to sort of paraphrase what you're seeing in the passage here, one way of analyzing these data is based purely on the model that happens after that propensity adjustment at the beginning. You calculate it in the usual way and you attach standard errors to it in more or less the usual way. Another approach, somewhat analogous to what you might do in a bootstrap, would be to say the propensity score is trying to arrange a situation where the treatment group is something like a random subsection selection of the whole panel of study counties. So why don't we do a permutation analysis where we randomly pick other groups of counties of the same size as that group and treat that other group of counties as a pseudo treatment group, and then we refit the same model, see what coefficient it gets. A comparison of the real coefficient to those quasi-coefficients ought to replicate the answers of the original analysis that was published. And Kessner reports that this analysis of his did not achieve that replication. Rather, whereas SLB had pretty soundly rejected the null hypothesis of no effect of this law on mortality, when he reanalyzed it in this way, all of a sudden, he has the kind of thing that could roundly be explained by chance. Oops. So not knowing exactly what was going on here, I decided to look further, and the bulk of this talk is going to be about that follow-up investigation I did, sort of a replication of Kessner's talk, the motivation of Kessner's replication exercise, I should say. The motivation here and the connection to table 1 is that a propensity score stratification of any type is trying to emulate some form of a random assignment or the other. Maybe the problem was there. Maybe if we look closely at the table 1 that came with the study, we'll see some indication of what went wrong even well before this problem with replication of the outcome analysis. So whereas in my first example, I argue that it was sort of a false alarm that we wound up thinking there was something wrong with the experiment. Here there's going to be a hint that maybe there was a false non-alarm in the table 1. It was actually a table 2 that was published in the SLB study. So here we see what they showed us about the characteristics of their sample at the outset of treatment for the treatment group. You have demographics up there in the usual way, and you also have the mortality rates averaged across Massachusetts counties and comparison group counties in the period of time before the 2006 change in the law. And things look pretty good if you compare on a column by column basis, Massachusetts to control. And also if you look at it from the perspective of the p-values that are presented in this table, those are in that third column over there. But my take on this was maybe those are giving a good picture of what's going on. Maybe they aren't giving a good picture of what's going on in terms of comparability of this setup to what one would have expected to see after randomly selecting the counties. Were one able to do that? And the reason they might not be doing what we would like them to do is when you're conducting a separate test like this for each of those variables, you risk dispersing your power in all directions and not being in a position to pick up on a discrepancy that's there. So I came at it with an omnibus test that had been advocated by guess who, yours truly, and his collaborator Jake Bowers some years back. Getting hold of the vital statistics data for this, but not all of the data elements that SOB used. There were some that were a bit difficult to track down. I was able to very closely, but not exactly replicate their analysis. They had wound up with 513 counties as a comparison group for the 14 in Massachusetts. I wound up with 512, but the means that I got for the Massachusetts group and also for the selected comparison group were very similar to what you see in the table. Even so, when I looked at it with this omnibus test that I'll tell you about a bit more in a few minutes, you'll see that there was a strong indication of a problem here. The null hypothesis of the groups being the same or comparable was soundly rejected. So having introduced those examples, let me tell you about the analysis I did to go with this and to see how far this phenomenon went in the next case. There are really three research questions that went with this, the first of which I've already told you the answer to. If I looked at that table 2 or the data in the background for the SOB paper using an omnibus test, the one I like the best, would it have raised an alarm despite the fact that the variable by variable test did not? And the answer to that, as I showed you at the last slide without telling you what went into it, is yes, it would have raised an alarm. Follow-up research question to that one. Could you clear the alarm, create a situation that better resembled an experiment if we addressed the size of the counties when we were assembling the comparison groups? I'll say more about that presently. And there's a follow-up to that research question, depending a bit on how research question number 2 goes. That follow-up question was, if we can arrange a similar comparison, but one that looks good from the perspective of this test, will it alleviate the dissonance between the result that SLB got using what I'm calling a conventional wall type test approach versus the randomization test, the type that Kessner showed. So having told you the answer that we got when I looked at it using the test that Jake Bowers and I came up with, let me tell you a little bit more about that, starting with some backstory of that test. My collaborator, Jake Bowers, who is a political scientist and statistician at the University of Illinois, we got interested in the statistical properties of balance tests as we think of them when we dove into a political science debate about voter mobilization, which was itself turning on a debate within that field about whether a certain field experiment had a self-refuting table 1, just as the Medicare expansion experiment I started with was thought to have in the example. So we started looking at operating characteristics of the tests that were being brought to the debate. We were led to a test of this form that I have here that says, calculate the centers of the groups in terms of each of the covariates that you have, take the difference of the one from the other, and now look at this, the position of this thing in multivariate space relative to the origin, and it sort of boil that down to a scalar using a Mahalanobis distance sort of calculation. It's sort of a first cousin of Hotelling's t-squared test. And we implement this in the RI tools package in R. An equivalent formulation that we didn't point out in that paper, but is somewhat relevant to thinking about this example, is that you can think of the test as a conditional raw score test of whether a certain set of coefficients are zero in a logistic model. Marvin Zalin published some papers on conditional inference in randomized trials within the past 15 years or so. So here's a bit of a point of contact with the namesake for this session. What we found was that this procedure has much better type 1 error characteristics than a likelihood ratio test addressing the same question, particularly when you have more than just a couple of these baseline variables making a contribution. One aspect of our test that was a little bit unusual was that in clustered settings, we had a clustered setting there. And here in this example we're looking at now, the clusters are counties. In clustered settings, the X's that are relevant to figuring these formulas or fitting this model above are cluster totals. And that makes the test sensitive to differences in cluster size, even when you don't have cluster size appearing among the X's. Whether that is a feature or a bug is somewhat open for debate. We argued that it was a feature in part because size differences can wind up being an issue in outcome analyses. Certainly in the application of this test to looking at Massachusetts counties before and after the Medicaid expansion in relation to other counties, the size thing is making a real contribution to rejection of the null hypothesis. Your counties over Massachusetts are relatively large, and SLB didn't attempt to match counties for size. So here's a bit of information about the revised analysis that I did to fix the problem, at least according to my and Jake Bowers' test, as it pertains to that this analysis. SLB had fit a weighted logistic regression, weighting each county by its size, in order to discriminate Massachusetts counties from other counties in terms of the baseline characteristics. My revision is here expressed in R notation. The basic idea was I took the model specification that they used. I took out one variable, which was mortality in the year in which the change happened in Massachusetts. And I put in one more, which was just the log of population size at the outset. So now we have some adjustment for size. We still had 5 other variables worth of prior mortality counts. So I felt we were doing okay on that front. SLB had, after fitting the propensity score model, taken as their comparison set all of the counties that fell in the upper quartile of counties outside of the state of Massachusetts. When I do that exact same thing using my propensity score, I wind up with an omnibus p-value of 0.02, which is better than what they got, but still not quite as good as we like to see. I have a parenthetical there about a variation of the test we published on that in some ways is better adapted to the modeling setup they had. And it similarly wanted to reject this. So I'm ruling that that's too low. And I fell back to a fallback position rather than the upper quartile. I looked at the upper quintile. Remember that here we're trying to predict being a Massachusetts county. So almost by definition, the Massachusetts counties have high propensity scores on this score. The fallback position then was to take as the comparison set the upper quintile, the 20% at the top. And when you do that, the p-values increased. We wind up with something that isn't rejected by the usual criteria. It's a bit narrow, but I said this would be good enough. There's a reference here to another paper that argues, canvasses the argument that you don't actually need a multiplicity correction for the fact you did a test just before. The lesson for this particular mini investigation was that this is a place to stop. So we used that comparison set. Now we have 182 counties as opposed to the 500 or some odd counties that were used as a comparison set in the original paper. And that's due to the fact that now size of the county has been factored in, and this comparison set of counties are much bigger counties. We're able to research to answer the second of those 3 research questions in the affirmative. Moving on to the question of whether there is consonance or not between the randomization inference based upon this and what you would have got without taking those additional steps. To review Kestner's analysis, this was the critical paper. He replicated the negative binomial regression analysis that SLB had done. And like them, he fitted the coefficient on the intersection of being a county in Massachusetts and being after the year 2006. That's interpretable as a treatment effect. This is also the thing that SLB had done. And it was the permutations of that thing that led him to his conclusion about non-replicability of the original answer. But I did a little bit differently. I noticed that SLB had sort of taken a certain t statistic as the basis for the inference, which is to say they calculated a standard error in a particular way and looked at the ratio of the coefficient to that standard error. And that was the basis for their inference. So that was the thing that I permuted in this follow-up analysis. And when I do that, make that change in what's being done in this randomization test, as well as the change about the comparison set of counties, at that point, I wind up with a result that's fully consonant with the result reported in the original paper. How am I doing on time, Raphael? I'm basically at that last slide.
Yeah, we're over now.
We're over. Okay, so to summarize, touching up the size imbalance and using a test statistic for this test, closer to what SLB has done, it brings the randomization inference perspective on this more into line with the perspective they had taken. To summarize, so here are the references that I've referred to in the talk, and my summary points then would be my takeaway. Others will have a different takeaway, but from the two examples, I would urge the takeaway that the variable by variable strategy of doing balance tests was both too strong, it rejected too much in the first example, but also too weak. In the second example, it failed to raise a flag where raising the flag might have given an improved result. So a multivariate test is better. Related to that, for emulating a cluster randomized trial, if that's what one's analysis strategy is setting out to do, the size of the clusters does matter, but a little bit of size matching can go a long way. And my last takeaway is one null finding from the Social Security Administration notwithstanding, health insurance seems to be good for you.
All right, great.